Cybernetic Wearables Database. Luke DeMarco and Al Avilas. Hello, everyone. My name is Al Avilas, and this presentation covers our Cybernetic Wearables Database project created for the CS 213 Database Systems Management class. This project focuses on building a centralized SQL database system capable of integrating wearable technology data from multiple sources, including health monitoring, activity tracking, sleep analysis, environmental information, and glucose monitoring. The goal of this project is to demonstrate how database system and wearable technologies can work together to create a cybernetic feedback system capable of generating meaningful health and behavioral insights. In this project, we've designed and implemented a centralized wearable technology database. This database combines several categories of wearable sensor information into a single SQL-based system. The data sets include activity tracking data, health and biometric information, sleep monitoring data, environmental sensor data, and diabetes and glucose tracking information. By integrating all of these sources into one database, we are able to perform SQL-based analysis and discover relationships between human behavior, health patterns, and environmental conditions. The project also demonstrates the foundations of cybernetic feedback systems where wearable devices continuously collect information that can later be analyzed to improve decision making and personal health awareness. One of the major problems with wearable technology today is that the data is often isolated across multiple applications and systems. For example, sleep data may exist in one application while glucose data exists in another platform and environmental information is stored elsewhere. The fragmentation makes it difficult to analyze relationships between data sets and discover larger health trends. To solve this issue, our objectives were first to integrate multiple wearable and sensor data sources into unified relational database. Second, to analyze correlations between activity levels, heart rate, stress levels, sleep quality, and glucose readings. Third, to compare user performance and health outcomes both with and without environmental context. Overall, the project demonstrates how SQL databases can support advanced wearable analytics and cybernetic style feedback systems.
The database was designed using an entity relationship model. The user entity serves as the core entity in the system, and connects to multiple data categories. The time record entity acts as the timestamp anchor that synchronizes wearable data across different data sets. So we wrote a couple queries that can show you some of the data that we recorded. This one here. This one shows how someone's mood can impact calories burned. We have the result. We have the query up here, and then all of the results are down here. This one here also shows how sleep duration affects physical activity performance. This one was done and records sleep duration hours as well as average steps and average calories. This query here shows exercise intensity, how often each stress level occurs at different levels of it. We have exercise intensities here, stress level there, and the frequency at which the stress level occurred. Entity relation. This slide displays the entity relation for the wearable database system. The user table acts as a parent entity while the remaining tables store specialized wearable information. The one-to-many relationships shown here allow a single user to generate many wearable records over time. The ER model also provides a foundation for future expansion, including additional sensors, AI analysis systems, and cybernetic monitoring applications. So we had several key findings with this project. First, higher physical activity levels correlated with higher heart rate and calories. Second, moderate activity levels correlated with lower stress readings. Third, users with improved sleep had improved performance and stable biometric measurements. Fourth, environmental conditions influenced activity and behavioral patterns. And finally, physical activity appeared to contribute towards improved glucose regulation in a diabetes dataset. In conclusion, this project successfully demonstrated how wearable technology can be centralized into a relational SQL database system. Product also demonstrated the importance of SQL databases for wearable analytics and cybernetic feedback systems. In the future, this system could be expanded with additional normalization, larger datasets, real-time streaming, machine learning analysis, and AI-assisted healthcare monitoring. Thank you for watching our presentation.